Good morning, scholars. Welcome back to the channel. This morning we're going to look at some sequences that are a little more advanced, a little more complex than just an arithmetic sequence or just a geometric sequence. These sequences are either combination of arithmetic and geometric, or they might be following a different pattern, for example, using indices. So in which case they would be advancing or decreasing exponentially, much bigger or much smaller than just simply multiplying by something or adding something, right? So when we're working with powers or exponents, that's where the word exponential actually comes from. Something is increasing exponentially each time it gets vastly bigger. Alright, so let's look at some definitions. It says some sequences are a little more complex than simply an arithmetic or geometric pattern, right? It might not be that you're just adding something, or you're just taking away something, or you're just multiplying by something, or you're just dividing. It could be a combination. You could be multiplying by something and then adding something, or multiplying by something and then subtracting something else, right? They might be a combination, or might involve indices or powers as well. So they want us to figure out the pattern and complete the sequence. So remember, for these, it's not just that we're adding something, or it's not just that we're multiplying or dividing by something. It can be a combination. So let's try and figure out then. So we start with 5 and we get 13. Alright, so first try and see, is it an arithmetic sequence? Are we adding the same thing each time? If I start with 5 and I get 13, that means I would need to add 8, right? And from 13 to 29, then I would be adding 16. So it seems to me it's not just, I'm not just adding, because the common difference is not the same, right? And I'm not multiplying them by the same ratio either, because these are not common. There's no ratio that will multiply 5 by to get 13 and 13 by that same ratio to get 29. So it seems like we're multiplying each term by something and then adding, since they're getting bigger each time. What are we multiplying by and what are we adding? A good method is try dividing each term into the next and see if you get a remainder, right? And see if when you divide the other term into the one after that, if you get the same remainder. So 5 goes into 13 2 times and we get a remainder of 3. 13 goes into 29 2 times, because 2 13s are 26, and we also get a remainder of 3. So it seems as if the pattern is we multiply each term. So let's call each term x. Each term we multiply by 2 and then we add 3 more to it. 5 2's 10 plus 3 gives 13. 13 times 2 is 26 plus 3 gives 29. Each time we get a term, we multiply that term by 2 and then add 3. So then that means we need to multiply 29 by 2. So 29 times 2, 2 9's 18, 2 2's 4, that's 58, and add 3 to that, so that will be 61. And then we need to multiply 61 by 2. That's 122, and add 3, that's 125. Okay? Alright, so let's look. 1973. We're clearly not adding the same thing. And we're not multiplying by a common ratio either, because 9 ones 9, but 9 nines don't give 73. So it seems to us that there's a combination thing going on. So let's divide. I would not advise for you to divide by the first term and then stick with that pattern, because many times the first term might throw you off. You really need to see what's happening further up, right? So if we divide 1 into 9, we just get 9. Which doesn't give us much, because 9 into that is 9. So let's divide this and see if we get a pattern, and then go back and see if this is obeying that pattern as well. Because the first, second terms can be obeying a number of patterns. So you can't use them really to pinpoint. Pinpoint it with other terms, and then you come back to check the first two terms, right? Because they can be following different, they can comply with different rules, the first two. So 9 into 73, 9 into 73 goes 8 times, plus 1 remain. So let's see if this is following that pattern. Alright, so if we multiply 1 by 8, 8 ones 8, and add 1 to it, we also get 9. So you see, the 1 and the 9 are obeying different rules. 1 times 9 gives 9. 1 times 8 plus 1 also gives 9. And 9 times 8 plus 1 gives 73. So that is the rule. So in other words then, we multiply each term by 8 and add 1 to it. It's not the each term times 9, because these don't obey that. So now we need to multiply the 73 times 8. 8 3 is 24, 8 7 is 56, and 2 58, and add 1 to it, that's 585. And we need to multiply this by 8 and add 1. So 585 times 8, 8 5 is 40, 8 8 is 64, and 4 is 68, 8 5 is 40, and 6 46, plus 1. So that's 4 6 8 1. Alright, so we have 2, 8, 20, 44. Remember, the first two might be obeying several different patterns. But let's just check. 2 to 8, that's multiplying by 4. We know it's not arithmetic, because you'd have to add 6, but this add 6 don't give 20, and this add 6 don't give that. It's something different than an arithmetic sequence. These numbers are going up by much more than a common difference. So it's not the 2 times 4, even though these two obey that pattern, but that pattern is not consistent with the others. So let's see, 8 into 20 goes 2 times remainder 4. 20 into 40 goes 2 times remainder 4. 20 into 44 goes 2 times remainder 4. Let's go back and check this then. So if we multiply 2 by 2 and add 4, do we get 8? 2 2's 4 plus 4. Yes, we do give 8. We do get 8. So we're multiplying each term by 2 and then adding 4 to it. So 44 times 2 would be 88, plus 4, that's 92. And 92 times 2, that's 184, plus 4, that's 188. Okay? Alright, now these are special numbers which you should know. They are not obeying an arithmetic pattern. You'd have to add 3, add 5, add 7, and so on. So what pattern are they obeying, right? Looking at these numbers, these are numbers you should know. These are square numbers. You should know these just out of your head. This is 1 squared, 2 squared, 2 times 2, squared, 3 times 3 give 9, 4 times 4 gives 16, 5 times 5 gives 25. So then we would have 6 times 6 and 7 times 7. So make sure you know these numbers, the square numbers. They come up a lot in sequences, and you shouldn't have to be trying to figure them out. As soon as you see the list of the set of square numbers, you should know. Here they are again, but this time they are descending. Here they were ascending. So they are descending here. 10 squared, 9 squared, 6 squared, 5 squared. So what's missing? 8 squared and 7 squared. So that would be 64 and 49. So they can either give you the square numbers ascending or descending, just look out for them. These also are special numbers. These are the cubed numbers. 1 times 1 times 1, 2 times 2 times 2, that's 8. 3 times 3 times 3, that's 27. So now we need 4 times 4 times 4. 4, 4, 16, 16, 4, 64. 5 times 5 times 5, that's 125. And 6 times 6 times 6 is 216. So it comes in very handy when you're doing sequences and otherwise too, generally in math. You should know your square numbers, whether in ascending order, descending order, you should know them, at least up to the first, let's say, 20. I think you could know the first 20 square numbers, starting with the first square number, which is 1. So 1 times 1, 1, 2 times 2, 4, 3 times 3, 6, 4, 4, 16, 5, 5, 25, and so on. They can also give them to you in descending order, so still know them if they're decreasing. And your cube numbers. 1 times 1 is 1, 1 times 1 times 1 is the same one. So 1 is the first square number and the first cube number as well. 2 cubed, or 2 to the power of 3. 2 times 2 times 2 gives 8. 3 times 3 times 3 gives 27. 4 times 4 times 4 gives 64. 5 times 5 times 5 gives 125, and so on. So you won't be there trying to figure out what are they doing. These numbers don't seem to be adding anything or multiplying anything. What are they doing? So you should not be there trying to figure out the square or cube numbers, right? You should know them. Alright, now this says a sequence obeys the pattern 3x minus 4. Complete each sequence. So they're saying each of these sequences obey the pattern 3x minus 4. So we're simply going to, for each value that we get, each term we get, we're going to multiply it by 3 and subtract 4 to get the next one, right? So 3 4 is 12, minus 4, that's 8. 3 8 is 24, minus 4, that's 20. 3 times 20 is 60, minus 4, that's 56. Alright, let's plug 5 in where x is. So 3 5 is 15, minus 4, that's 11. 3 11 is 33, minus 4 is 29. 3 times 29, so let's work that. 3 times 29, 3 9 is 27, 3 2 6 and 2 8. That's 87 minus 4, and that will be 83. Alright, so if we have 9, 3 9s, 27, and 27 take away 4 is 23. 3 times 23, that would be 69. Take away 4, that's 65. And 3 times 65, 3 5 is 15, 3 6 is 18, and 119, 195. Take away 4, 191. Again, it says a sequence obeys the pattern 5x plus 1. So here they are telling us what the pattern is. They're not saying figure out the pattern and complete the sequence. They are telling us what the pattern is that the terms are obeying. So we need to just plug each term into that pattern and keep getting a new term. So 5 6 is 30 plus 1, 31. 5 times 31, 5 ones, 5 and 3, 5 ones, 5, 5 3 is 15, 155 plus 1, that's 156, and 5 times 156, 5 6 is 30, 5 5s, 25 and 3, 28, 5 ones, 5 and 2, 7, 780 plus 1, 781. Alright, how about if it's 12? 5 12, 60 plus 1, 61. 5 times 61, that's 305. 5 1 5, 5 6 is 30, 305 plus 1, 306. And 306 times 5, 5 6 is 35 is 15. 1,530 plus 1, 1,531. And finally, if we're starting with 1 and following the pattern 5x plus 1, 5 ones 5 plus 1, 6, 5 6 is 30 plus 1, 31, and 5 times 31 is 155 plus 1, 156. Alright, so that is our look at the more advanced sequences at this level. So remember, sequences don't always just go up in an arithmetic order or just a geometric order. Sometimes we combine them, or sometimes they go up exponentially. So we have to look out and we have to know our special numbers. Know your square numbers, know your cube numbers, right? And just try and figure out. So the first 2 terms in the series can be a little tricky because it could be that they're following different patterns. The first 2 can sometimes be following a number of patterns. So consider from the third term onwards, try dividing it into the next and see how many times and what's the remainder, and then see if the others are following that pattern. Go back to the first and second, see if they're also following that pattern, right? So we're looking at combinations of operations. Alright, so if you have benefited from this video, just drop a line to say thank you, miss, and let me know if you want me to do videos on other topics. Please share the video as well so others can benefit. And if you have not subscribed to the channel, do so now so you can benefit from more videos. So my scholars, take care, and I'll see you in the next video.